Today sees us finally lifting the lid on the latest Intel Core Ultra range of processors in terms of performance and everything you need to know about the newest generation of CPUs, along with some big changes and how they compare to the 14th generation Raptor Lake parts. But before we get into that, here's a quick word from this video's sponsor.
I'm never going to be an esports gamer. I never get any kills.
I wouldn't be so sure of that.
Is that Andy Raffel from eTeknix.com?
Yes, my son, it is me, Andy Raffel from eTeknix.com.
What are you doing here?
I'm here to bestow upon you a gift that will transform you into a true gamer. With a 24.5-inch Full HD screen, 240Hz refresh rate, 0.5 millisecond response time, AMD FreeSync Premium, and height adjustability, you'll be gaming in the big leagues in no time.
Thank you.
No problem, my son. Why don't you check out the link in the description below to find out more.
Okay, so let's break down what the latest generation has to offer, starting with the big changes, with the first being the naming structure. Gone are the days of the Intel Core i series and instead are now branded as the Core Ultra range of CPUs, with U5, U7 and U9 given a clear shift into differentiating between processors of old and this whole new lineup. Initially, consumers were expecting a 15600K, 15700K and 15900K making up the bulk of the range, but instead we now have the U5 245K, U7 265K and U9 285K, with obviously KF versions for some of the SKUs for those who want to maybe save a bit of cash by ditching the onboard GPU cores. Now, Intel have also put a big focus on improving the overall user experience with this new lineup and delivering better performance per watt, something that was, I guess, a key and distinctive point behind the 14th gen that were known to use significant amounts of power, especially on the higher end i9 parts, which ultimately resulted in, well, a lot of heat and was a common complaint among the community, resulting in thermal throttling if your cooler wasn't up to the task and consequent BIOS updates that could fully unlock the power limits of the CPUs to give their full potential. Intel's claims for the new Arrow Lake set of CPUs set clear goals of reducing package power by up to 40%, all while maintaining gaming performance and reducing package temperatures by up to 10 degrees C while gaming. Along with the all-important AI acceleration, because as we know, that's where the big money is right now. So there's kind of a focus on that. So going into this, if you're expecting huge leaps in performance, I think it's clear to see that's not the end goal, but instead is to offer the same performance as Raptor Lake 14th gen processors while significantly reducing power. And there's one big thing that they've done to potentially achieve that goal. Hyper-threading is now gone. A technology that's been with us since the Pentium 4 days. And yes, for those who are as old as me, we're going back about 22 years. So with the lack of hyper-threading, looking at the new Core Ultra series, you'll be fooled to see the specs come in lesser than the predecessors. For the top of the range Core Ultra 9 285K, we now have 24 physical cores made up from 8 performance cores and 16 efficiency cores. So essentially identical to the 14900K and KS, but now with no hyper-threading. So instead of 32 threads, we now just have 24. But they're all physical cores, and that's kind of, I guess, the key difference. Moving down the stack is the Intel Core Ultra 7 265K and KF, which comes in, as you'd expect, slightly less with 20 cores, made up of 8 performance cores and 12 efficiency cores. So again, matching that of its 14th generation counterpart, but again, we lose 8 threads this time due to the lack of hyperthreading. Then the Core Ultra 5 245K and KF comes in with 14 physical cores, made up of 6 performance cores and 8 efficiency cores. So again, coming in with less overall threads when compared to the trusty Core i5 14600K. Now, the changes don't stop there though. As we look at clock speeds, things have moved quite dramatically in some cases, with less overall speed with the Core Ultra 9 now coming in with a max speed of 5.7 GHz, which is a hefty 300 MHz lower than the max turbo frequency of the 14900K. The Ultra 7 265K comes in with a max speed of 5.5 GHz, which is 100 MHz lower than its predecessor, the 14700K. And then the Ultra 5 245K comes in with a max speed of 5.2 GHz, which is again 100 MHz less than the 14th gen equivalent 14600K. So some pretty stark differences in core counts and speeds. And well, the changes don't stop there. Intel have been making admittedly small strides in their Arc discrete GPU technology and are now wanting to bring this to their desktop processors for the very first time. So a bit of a change up from the UHD graphics that we saw on Raptor Lake refresh processors. Consider those as Intel Z low power architecture, whereas now we have Z high performance gaming architecture, or HPG for short. This should Well, assist in more graphically intensive applications, including gaming, content creation, and of course, that all-important buzzword of the moment, AI. So how is all of this made possible? Well, Intel have taken a leaf out of AMD's book in terms of 3D chip stacking. Now, unlike AMD's 3D V-Cache technology, Intel have taken a slightly different approach. While the process still involves 3D stacking, Intel's Foveros technology allows multiple tiles, so similar to what would be referred to as chiplets or dies, to be stacked vertically on top of each other. And this is likely why the new range of processors, while looking very similar, actually has a slightly slimmer, in terms of width, IHS. Now, beyond the visual aspect, there's a lot of good reasons for the change, including reduced power consumption by shortening the distance signals have to travel between layers, and also reducing latency between the different tiles, while also improving efficiency due to the shorter interconnects. And, well, this isn't the first time that we've seen Foveros, as it was used in Intel's Lakefield lineup of products, which used the hybrid big-little architecture, similar to what ARM do. Now, we also have support for faster memory as standard, something that Intel has always been at the forefront on. So, along with JEDEC supported speeds of up to 6400 MHz, we now have increased capacities of 48 gig DIMMs, and a total of 192 gig, along with ECC support and support for the new CU-DIMM standard that brings faster memory speed support through XMP. Now, if you want to find out more about the memory, we do actually have a video on that, so go and check that one out, it's on the channel. Now, we also have a new socket with 1851 pins. Now, I say new, but the socket's pretty much the same, it's just more pins, so you can use your existing coolers. But this brings a new chipset in the way of Z890, which we'll be covering in our motherboard content, so be sure to check that out, as well as the content that we already have on it on the channel. Now, combined between the CPU and chipset, we now have up to 48 PCIe lanes, of which 20 are PCIe Gen 5, along with a huge host of USB options in varying speeds, and up to 2 Thunderbolt 4 ports as standard, as well as Wi-Fi 6E, Bluetooth 5.3, and Gigabit Ethernet straight out of the box. Though motherboard vendors could add up to 4 Thunderbolt 5 ports, Wi-Fi 7, Bluetooth 5.4, and faster Ethernet capabilities if they wish. Okay, so specs and technology aside, what can we actually expect from the CPUs that we have here? Well, Intel claim, and this is important because every brand over-embellishes, but they claim up to 58% lower package power in lightly threaded work compared to Raptor Lake Refresh. They also claim up to 8% faster performance in single-core performance compared to the generation before, along with up to 4% faster than the latest flagship 9950X from AMD. On top of this, we also get up to 15% faster multi-threaded performance compared to the 14th gen, and up to 13% faster than, again, the 9950X. So while this new lineup isn't focusing on huge performance gains, they're definitely still there. But it's clear, based on our talks with Intel, that the big focus is on power efficiency. Something that AMD did with their 9000 series, but just forgot to, actually tell people. Now, to give some context on it, Intel have given some indications as to what it means for overall power, with a claim that you can get similar performance within margin of error while using 80 watts less power. They also show power efficiency figures in 7 games, where they use between 34 to a pretty staggering 165 watts less power on the new Core Ultra 9 285K. So let's get to the real reason you're here, to see if Intel's bold claims hold any merit, which is where we come in with our own testing. Now, I'm not expecting huge uplifts in performance, but anything is welcomed, especially if we're talking about getting the same or more performance, but for less power. Now, I'm under no illusion that consumers don't wholly care for lower power, but performance works kind of hand in hand, because less power means less heat, and that means a smoother experience overall, as you'll be hitting the max level of boost for a sustained period of time. Now, to test, we use the MSI MEG Z890 Ace motherboard with the latest BIOS, along with 48 gig of Kingston Fury Renegade 8200 MHz CL40 CU-DIMM memory. For all of our CPU tests, we use the Inno3D RTX 4090 iChill X3OC to rid the system of any GPU-based bottlenecks, and for testing, we use Windows 11 23H2, as 24H2 has some major issues with the newest official release on Arrow Lake. We also used the latest drivers for both the chipset and GPU, and we tested a handful of synthetic benchmarks along with 10 games to show how good the processors are in both workload-related tasks as well as gaming. And we'll be putting the CPUs through their gauntlet of over 40 games in the very near future, so make sure you're subscribed for that. We'll also be putting a big focus on power and temperatures for our tests, as this is where these CPUs should, in theory, shine, at least according to Intel. And I will now say, as a word of warning, that unlike previous generations where we typically see a generational uplift, Arrow Lake is a bit of a weird one, because in applications and games that can harness the potential, it does well. But where we're also losing hyperthreading, you will see some anomalies compared to the likes of the 14th gen. But this could all come down to optimizations within the application or the games. So, with that out of the way, let's get into those glorious benchmarks. Starting things off with 3DMark's CPU profile benchmark, and things are already off to a good start. The U5 245K sees a healthy 11% increase in performance in single core and a pretty staggering 24% improvement in multi-core when comparing to its predecessor, the 14600K. The U7 265K sees strong improvements too of 11% in single core and 19% in multi-core when compared to the 14700K. While the U9 285K flagship sees the strongest single core gain over the 14900K of 13% and a 23% uplift in max threaded workloads. This also puts both the U9 and U7 ahead of the 9950X in both single thread and max thread results, so it's good and a strong start from Intel. In Blender, we again see some strong gains across the board when comparing the new Core Ultra series to the 14th gen predecessors, with a 12% uplift on the Core Ultra 5, 14% on the Core Ultra 7, and a 20% improvement with the Core Ultra 9. Compared to the competition, this again puts Intel ahead with the Core Ultra 9 when comparing to the flagship 9950X from AMD, albeit only by 3%, which is right on the cusp of margin of error. In Corona, this time we're looking for the lower the number the better, and AMD have this one sewn up, coming in with the best result at 35 seconds, though Intel are only just behind on the 285K at 39 seconds. Now, when looking at the previous generation, the CPUs do suffer somewhat here, coming in slower, which is likely down to the lack of hyperthreading. But optimizations through drivers and software development could see things improve over time. Because while the U9 and 14900K are close, the U7 and U5 are separated quite dramatically from the processors they're replacing. In PCMark 10, it's another blow for the new Core Ultra series. Not only are AMD storming ahead by quite a large margin to the tune of just under 17% from the 9950X, but the 9700X and 7950X also fares better, along with the complete 13th and 14th generation CPUs that we tested. When you have a 13600K i5 coming in with a stronger score than a Core Ultra 9 285K, then you know some performance has been left on the table. And optimizations again should help dramatically, though it could all be down to hyperthreading now being eliminated, though I suspect it's more of the former than the latter. In our last synthetic test, Cinebench 2024 showed strong performance across both single core and our multi-threaded workloads. The U5 saw an 8% uplift in single-threaded performance over the 14600K, along with an 11% improvement in the multi-core test. The U7 saw a smaller but still healthy 6% increase over the last generation single-threaded result, and again 11% in multi-threaded over the 14700K. And then the U9 saw a slightly better 13% in single core and an impressive 17% uplift in multi-core, which also puts it ahead of AMD by 6% in single core and 16% ahead in multi-core. So it can now be argued that Intel hold the crown again for the best performance CPU, but we do need to look at games to see how that translates. Our first game up is A Plague Tale Requiem, where all three CPUs give us an uplift compared to the previous generation. Now the uplift on the U5 is the strongest at 8%, while as we move up the stack it does taper off somewhat, with a 6% improvement for the U7 265K and a slightly lower but still welcomed 5% on the U9. Though with figures coming in nigh on identically, we are being held back somewhat. Something that didn't seem to be a problem for AMD, which already held a strong lead over the 14th gen, but now further improves that with our best performance coming in from the 9950X, which sits around 8% faster than Intel's newest offerings. I can only assume that in this it's down to the scene that we actually test it in, and we may actually revamp our testing for this particular title. In Asseto Corsa, it's a bit of a mixed bag. The U5 starts off strong with an 8% uplift in performance gen to gen, while the U7 actually sees a performance hit of 2% when moving up from the i7 14700K, and the same 2% variance between the 14900K and the new U9 285K. And this further strengthens the lead to both the 9950X and that monstrous 7800X 3D, which takes the top spot by a hefty 22% over the 285K. Baldur's Gate is a game that is frankly a bit of a hot mess for this new series of CPUs and is a bit of a nightmare to test due to its inconsistencies anyway. What we find is that AMD lead the pack with the 7800X 3D as expected, but even the 9950X holds a strong lead over the new lineup now, whereas before the 14900K was still holding strong. What we see generation to generation is even worse for Intel, with a 6% drop in performance on both the U5 and U7 and a pretty dismal 15% drop on the U9. Though again, optimizations could help, but who knows when they're coming to play. Cyberpunk shows some pretty weak performance again, with some sizable drops in performance. All three CPUs come in very close to each other, between 85 to 87 FPS, and this translates to between a 13 to 15% loss in performance compared to their predecessors. Now, we further confirmed these losses with other media outlets in the industry who experienced exactly the same deficits. So again, I'm hopeful that optimizations can help, but that's quite a big void to fill. In F123, we're always expecting AMD to do better than Intel, as was the case with all generations before it, and AMD still holds strong on the likes of the 7800X3D, 7950X and 9950X, and sees the 9700X coming in within similar performance to the 285K U9 CPU, which has seen a 9% improvement in performance over the 14900K, which is welcomed, along with the U7 sporting a similar 10% improvement over its predecessor. Sadly, the U5 suffers somewhat and actually loses performance, though we're only talking 1%, so margin of error rearing its ugly head, so we'd class that one as identical anyway. In Hogwarts, the only CPU that gives us any performance improvement was the U5, which comes in with 3% higher frames than the 14600K, while the U7 and U9 both match their previous generation counterparts in the averages, though the U7 did sport a better 1% low when compared to the 14700K, though in comparison this was quite a bit lower than the 13th generation 13700K, though the averages still show margin of error coming into play in places. Next up is Spider-Man, and again the U5 gives us the biggest uplift of 14% over its predecessor, now coming in at 210 frames per second, which also matches that of the U7, which pushes another 7% performance over the 14700K. This uplift is also identical to what we now see from the U9 285K when comparing the data to the 14th gen flagship 14900K, and it's enough to see Intel hold the crown in this title even when compared to the 7800X3D. Shadow of the Tomb Raider is still a game that can really push the potential of different CPUs, and while the 7800X3D takes the top spot at 288 frames per second, Intel do still manage to find a small amount of extra performance with this new lineup. For the U5, when compared to the 14600K, we now have 5% more frames being pushed to us, while the U7 sees that drop to just 3% when compared to the 14700K. And then the U9 sees it increase again to 5% when comparing the data to the 14900K, and this is enough to take on AMD on all processors, minus the 7800X3D. In Starfield, AMD holds strong, but Intel just has the edge with their last two generations, even when compared to the 7800X3D. But the new Core Ultra improves on that even further. We now see a small 1% uplift on the U5 245K, while the U7 sees a stronger 5% improvement over the last generation equivalent. And then the U9 285K takes the crown thanks to a 9% improvement over the 14900K, and this puts it 9% ahead of AMD's best offering in this title, which is the 9950X. In our last gaming test, which is admittedly one of the most CPU intensive games, well, it's bad news for Intel across the board. Not only do all three of the new CPU lineup come in with identical performance, it's some pretty stark drops compared to what we had before on 13th and 14th gen equivalents. The U5, for instance, loses 10% performance moving up to its latest lineup, while the U7 sees that drop even further by 12%, though our worst hit comes by the way of the U9, where we lose a sizable 14% in performance, further cementing AMD's lead over Intel, which was already strong when compared to Raptor Lake's 14th generation. So that was a bit of an interesting one, which is actually nice because normally it gets a bit monotonous when comparing one generation to another, but thanks to the removal of hyperthreading and a whole new architecture, it actually gives us something more to talk about, because performance was up in some areas and, well, down in others. Now, the real reason you're likely here is gaming. So let's put a big focus on that, because that really comes down to a few things, including game engines, utilization, and how the game interacts with what instructions are on offer. And I think it's clear to see that there is potentially performance left on the table that could be found through refinement by the game developers, mainly when you look at titles like Cyberpunk, or other games like Riftbreaker. Well, I think that's a different story. Because of the type of title that it actually is and how it interacts, I think the loss of hyperthreading and speed has maybe taken a bit of a hit there. As always, to get a better idea as to kind of what's going on, it's worth taking a look at the overall average FPS. It's here where we find, well, not much. The U5 245K comes in at 174 FPS on average across all 10 games, compared to 172 FPS on the 14600K, which equates to just 1%. So retesting could see this come in even closer, so for the sake of being fair, we'll call it identical. For the U7 265K, that too came in 2 FPS higher than its previous generation counterpart, so again 1%, so neither here nor there. Then for the U9 285K, we see no change when compared to the 14900K, as it comes in identically at 187 frames per second. When factoring in the cost of the CPUs, this results in a cost per frame of $1.78 for the U5 245K, $2.18 for the U7 265K, and $3.14 for the U9 285K, which are all higher than the 14th generation, but as always, this is based on the cost of these CPUs now, which are inflated somewhat due to them being new, compared to the 14th gen, for instance, which has seen prices tumble since their launch. But if you're looking at launch price to launch price, they do come in exactly the same, and you could basically do the sums and work it out for yourselves. How this now compares to AMD is comparatively close to the likes of 9950X, again being a new product when putting it against the U9, while the U7 is closer to that of the 7800X3D, though that comes in much higher in the average FPS. Then the U5 is comparable to the 9700X, which offers up slightly more performance, but comes in slightly higher in overall cost. Now, I said at the start that these CPUs are all about power and efficiency, and well, that's very much the case, because Intel have seemingly listened to the complaints set out by consumers when it came to the 14th gen, and mainly on the higher end i9 parts. That's why we measured power consumption at idle and during Cinebench and also during gaming. And it's here where at idle the new Core Ultra CPUs really do excel due to their efficiency cores and how the architecture is actually working. We typically see figures around the 15 watt mark while sitting on the desktop, which is a significant improvement over the 14th generation, and now also comes in much lower than anything AMD have to offer. During load, the U9 tops our charts, matching the power limits of the 14900K, 14700K, 13900K and 13700K, but that's expected anyway. While the U7 comes in just between the 7950X and 9950X, and then the U5 coming in closer match to that of the 7700X. The total system power shows a slightly different story, with the U9 coming in closer to its predecessor at idle, but nestled between the 9950X and 7950X during load. So it's a bit of a win there for Intel. The U7 and U5 match each other at idle, but are quite different at load, with the U7 matching power with the 13600K and 14600K, so quite an achievement considering the extra performance. While the U5 is closer to that of the 7800X3D and below the 7700X, though the 9700X is still looking impressive here. In gaming and looking at the power and temperatures over an 8-game average, we find some significant improvements. Starting with the U9, which actually ended up using on average 79 watts less power than the i9 14900K, while the U7 came in using 61 watts less on average compared to the 14700K. And then the U5 came in using 56 watts less than the 14600K, and this also puts all three of the new CPUs in a much better place compared to AMD's 9950X, 7950X, and I guess you could argue 7700X. In terms of temperatures, this is another area where things get pretty cool, if you excuse the pun. The U9 285K now comes in 27 degrees lower than its predecessor, while the U7 265K comes in 26 degrees lower than the 14700K. And then the U5 245K comes in 24 degrees lower, and this also means that all three of these CPUs come in cooler than anything AMD have to offer, which, while it doesn't necessarily offer huge amounts of extra performance, it's a great selling point for consumers. So a lot of data that we went through, and I think it's clear to see that the removal of hyperthreading in applications hasn't had a huge knock-on effect in some pieces of software, while others have clear distinctions in regards to the performance that's now been lost. But, and this is just me being theoretical, the performance is there. It just needs tuning on an app-by-app basis to unlock what's, again, been left on the table. Now the same could be said for games, which I think does account for something in certain titles, while others just have clear and concise data that shows the performance just isn't there to begin with. Cyberpunk is probably the biggest one for drops in performance, and as said, we have had that confirmed with other outlets too, so at least we know that our data specifically isn't an outlier. The numbers are the numbers. Now, the cost per frame, well, that's a bit of an interesting one. Not only do we have new CPUs, but we also have a new chipset with a new socket, so there's an added cost there. And then the cost of memory, which is frankly astronomical. Now for our 14th and 13th gen testing, we used 7600 MHz memory, though due to the memory controllers, we did have to drop the speed down slightly in places to gain stability. While Arrow Lake does manage to sit comfortably with 8200 MHz memory through the CU DIMMs that we were using. Sadly, these come in, are you prepared for it? Around double the price of an equivalent 7200 MHz kit, as an example. So what I'm trying to say is there's a much bigger difference in total overall cost of the system. And for me, that's a bit of a sticking point. Now, I know there are consumers out there who will happily pay to have the bleeding edge latest tech and to be at the forefront of it all, but that's a very, very niche substrata of the consumer base and only accounts for a small percentage, while other consumers and gamers are going to be disillusioned from it all. Though we will be doing some memory tests on these CPUs in the near future to see what kind of differences, if any, faster memory actually gives you. For now, I think the chips are good. And it's almost showing us that this is what 14th generation maybe should have been, at least in terms of giving close or equal performance, but with a much more refined power delivery system. It's hard to say, but pressures from AMD could have seen Intel pushing out the 14th generation much earlier than planned, and they took some big hits on the bad press. While Arrow Lake improves on all of that, and as Intel aren't pushing huge performance gains in their marketing and instead are pushing kind of towards power efficiency, much like AMD have done with the 9000 series, but the key difference is Intel seem to have a stronger marketing message. Whereas, as I mentioned with the 9000 series, AMD just forgot to tell anyone the point of their new release. And that's where it all just got a bit confusing. Right now, I think it's good, but there's still some work to be done. And we will be putting these chips through more thorough testing, especially when it comes to gaming, as we do more tests in more titles to get a better, more well-rounded picture. So make sure you're subscribed for that, because that would just give us a better idea as to where improvements can be made, potentially through updates, whether that be through the games themselves or maybe even chipset driver updates, who knows. What is clear is that Intel have done a good job on refining this lineup, and it's, in theory, only going to get better. But at least now we have a series that doesn't need a refrigerator to keep them cool, doesn't need a power station to keep them running, and can still compete against AMD's non-3D V-Cache lineup, which is where Intel have always hedged their bets. Unlike the 7800X3D, for instance, which is a gaming king, Intel has always been strong in gaming while simultaneously being strong in workload-related performance too. The ultimate all-rounder, I guess, is where they're aiming these to be. And it's, for the most part, bang on the money, even if our particular setup will, with the motherboard and memory, cost you an arm and a leg. For now, that's about going to wrap this one up. Let me know in the comments section, which model are you eyeing up for your next build? Or are you going to go in a different direction and go with AMD instead? Let us know so we can kind of gauge where the consumer headspace is currently at. That aside, hopefully you enjoyed this video. If you did, a like and a sub to the channel would be amazing. And if you love what we do, consider supporting us over on Patreon, where you'll get access to exclusive behind the scenes content, bi-weekly game nights, access to our moving vlogs, and so much more. The link is, as always, down below. Thanks for tuning in, and I'll see you in the next one. See you later, guys. Bye-bye.